All right, let's design a voltage regulator's infusion transistor. So we want to create a new electronic design. All right, as usual, this is the page for electronic design. So we want to create a new schematic first. We need the schematic and the board layout, and then we got the 3D model. All right, so let's create a schematic. Let's create new. And for voltage regulators, so we want to select, want to click on this one to find all the component that we need. So for the regulator, we're gonna use the LM7805. So we'll be designing a voltage regulator that take 9 volts and then just cut it down to 5 volt. So we got 9 volt as the input, and then we get 5 volts. All right. So let's go power management. That's the good. I'm gonna do through holes. This is through hole just mean the the packaging. Okay, TO 220. All right, sounds good. Double click and then bring it in the canvas. All right, right there, and I click OK. So we're gonna need the input will be 9 volt and the output will be 5 volt. All right. So we also need to look at the data sheets which I have right here. So according to this schematic to the data sheet, we let's go to the simple application of it so we can see what do we need. So we need some capacitor here and another one here, kind of like have like a smooth out the voltage. All right, so I'm going to add a couple capacitors. So we want to select the library, the component. We want to choose capacitors. Let's clean up this one, and USA, that's look good. So for the capacitor, we're gonna go with 0805. It's kind of like the packaging. It's a little like a surface mount, also easy to hand solder. So I'm gonna select this one and then double click here and then break one here. We're gonna need 2 of them. Oh, forgot we should rotate that one. So let me click on middle mouse and then just rotate the whole thing. All right, let's click OK. Maybe we need to rotate this one more. So left click just to rotate and rotate this one. All right, so good to me. Maybe let's do something like this. All right, perfect. And yeah, I'm gonna need the ground, also the inputs. For that we need some connectors, so let's go for all libraries and then maybe select a GST for the connector. um Maybe not this one. Man, oh, that is good. We need 2 pin. Yeah, it's good. All right, we'll grab this one. We need 2 of them. Maybe rotate middle mouse. Perfect. And then rotate here too, middle mouse, just like that. One for the input and one for the outputs. Perfect. And let's see, maybe we need some LED, so when the current goes in, so the LED lights up, and then when the current goes out, we got the LED lights up again. All right, so let's go and see if we can get some LED here. Let's see, LED. Okay, we have LED right here. Clear this up. All right. LEDs. Let's see. This look good. All right, great. Okay, we're gonna need 2 of them. Yep. Let's put it down here because we're gonna need some resistors too. And one, second one there. Okay. And we need the resistor. Let's see, resistor, right? Sometimes you can search here, so type resistor, so easier when they have a little library in there. So go USA, say, alright, maybe we choose surface mount or something like that. So I'm gonna go with the Oro or 805. All right, so So we got surface mount all over the place. All right, middle mouse to rotate. Okay, this is not how I want it to be, but all right, let's put one there and one here too. Click OK, and then I'm gonna rotate. This is all right, perfect. Great. All right, and we're gonna need some ground, so let's go. That will be this all, and then go to power. Maybe GND some ground. Double click, and then oh, maybe not this one. No, we don't want that one. Let's see. Okay, this one look better. All right, need a ground for the inputs. Perfect. I'm gonna need one here, and maybe put just one here so we can connect all of them. Okay, it's perfect. Let's put it right here. I'm gonna need one for this one too. It's quite a lot. You don't need that much, but doesn't matter. All right. I think I got all the component I ever need. So let's go ahead and wire the whole thing. So to wire, you want to click on this net thing or click on R like a shortcut, just like that. Or click right here, and then you just grab you just go in there and wire the whole thing, like that. And this, all right, this is all right. Maybe let me see if I can move this one a little bit up there. All right, looks about right. All right, R again, and here we go, just like that. And go right there, and okay, let me move this one. Oops, all right, let's see, I'll move the whole thing. All right, step about right, R again, and there we go. Ground. Like I say, you don't need that much ground, but that's one way to do it. All right, this is going to the ground, and this one will be here. Those are just there to smooth out those capacitors, to smooth out the voltage. One more there, and all right, I should remove this one, but it's fine. All right, so when we got the 9-volt battery voltage coming, the LED will light up, like I saying that okay, there's a voltage, and those are just to smooth out the voltage. And this is the output. All right, let's see, I need to power my Arduino, which use 5 volts, so plug one here and then put everything to the common ground. All right, I don't need this essentially, but I still can have it, but it's fine. It's a ground. I could just use one ground and then connect everything together, but there's multiple ways to do it. All right, next step, we need to add some values. For the LED and the resistance here, I'm just gonna go with some random values. But if you want to design a real one that you want to use for your Arduino, like I said, you have to use the Ohm's law. So calculate this one. Let's go like 450 or something. Maybe I don't know, 0.5 kilo ohms resistors. You the same here too, 4.7 kilo ohms resistor. Use Ohm's law. Let's say the voltage drop here is let's say 1.8. So the voltage across this branch is the 9-volt that comes in. This one take 1.8, and then you subtract it from and then you get the voltage here, and you can use Ohm's law, and then you determine the resistance that you need. All right, I think I got everything in here. We got the resistor, the lights, and yeah, the output and everything. What I want to do next is just do some checking here and see if we get everything right. So I'm having some errors here. Okay, the LED doesn't have values. All right, that's fine. Can fix that one too. So let me check for the LED. This one will be green. All right, let's say green, and this one will just be red. So that's like the input, right? The inputs will be green, will be red, and then the output will be green. And let's run it again, Let's see if that fits everything. Okay. Oh, the capacitor. Okay. From the data sheet, this one. Okay, I need some value for it. Click on the values. This one from the data sheet, that's 1.22 microfarad. Okay, maybe not capital. All right, perfect. And this one, it should be 0.1 microfarad. All right, and let's run the validation one more. The electrical road check. All right, no more errors. Perfect. Let me save this file first. All right, we're gonna call it voltage regulators. Sorry, voltage regulators. Sorry, regulator. All right, and click on save. Perfect. All right. I name this one voltage regulators. I'm gonna name it schematic, but it's fine. All right, now we want to switch it to the PCB layout. All right, so it's like on the 3D board. There we go. So we got all our component right here. We're gonna put them right in this one right here. So for the board, maybe we should design our own, but I'm gonna use the one in here. It's way simpler. Okay, so I'm gonna reduce this one quickly since we don't have that much components, and then keep with your middle mouse to grab it up there, and we'll start laying out stuff here. So I'm gonna move all the irregular stuff right there, and then for the capacitor, let's see what I'm gonna put them. The LED one's gonna be right here, like about there, and the second one will be here. I think so, just like that. I might need more space here, so let me extend this one a little bit, and I'll put this one right here, and this one can be about there. This one down here. So, alright, maybe we need more space. Let me just do it this way. Alright, and I can put this one right here, and this one up there. I'm gonna kind of rearrange it later, okay? Now, C1, let me look up my schematic here. So, this is C2 and then C1 on the other side. Alright, this is C2, C2 have to be somewhere in here. We can still rotate here too. So, this one, alright, that's good. So, maybe not. Alright. The C1 will be just somewhere in there. Okay, maybe rotate a little bit. Okay, perfect. The R1, let me check the schematic again. This is R1 and R2. Okay, R1 will be right here, and R2 will be right here. Okay, let's see if I can rotate this one. Alright, you gotta move things around a little bit and see which one works for you. Alright, this doesn't look good. Let me see. Alright, let's move this one. What about there? Okay, this will be there. LED. Put this one up down here. Let me see if I can rotate one more. Oops. Alright, that looks about right. Those little lines are called air wires, so you're gonna make sure they don't run over each other as much as you can. Let me see if I can rotate a little bit. If not, then we'll keep it that way. And now we're probably gonna use some vias. All right, this is gonna really. Oops. All right. Let me see. I seem to get this one to work. All right, we're gonna leave it that way. Maybe we'll use some VR to kind of solve that issue. All right. Remove this. Oops. Mm, this one a little bit closer. Maybe we can rotate this one. Let's see if I can get it. Maybe not. Let me rotate it time. Alright, we'll keep it as that. And then I'll move this one close to here. Resistors. This one. It's a little bit hard to. Oops, that's not what I meant to do. So I'm gonna rotate. Alright. Uh-oh. I can now rotate things. Let's see. Right there. Alright, you know what? I'm gonna stop here. We'll use VI and then solve the whole issue thing here. I don't like this. It's just a little tedious work. Alright. And those components will be all over the place, but doesn't matter. Alright, the board looks about right to me. Now what I'm gonna do is add some polygon pole so we can connect all the ground to the copper plate. So we want to use the top. I should mention that here I'm using like 2 layers. So some complex PCB might be using like more than 2. So this is the top one. It's like the top and then the bottom. The bottom is right here, and then we are on the top. So I'm gonna pour the copper on the top. So I'm gonna click on this one, select one of the edges, and then we want to pour on the top. All right, click OK, and then we want to connect it to the ground. So the ground will be connected to the board, just like that. And now we'll do the wiring. We could use the manual wiring, but here I kind of have an issue like laying out my components. So what I'm gonna do is use the auto wiring. If that doesn't work, then we'll use the manual way. All right, let's run it. So we have the top and then the bottom. I could set the bottom to none so we don't want any wiring, but I'm going to leave it to auto. And we can just play around here, see which one works for you. This is a simple one, so I'm going to go for the F4, go for high. It might take a while to kind of, for the algorithm to kind of find the right wiring. So I'm going to go ahead and click continuous and then start. All right, so here you want to select the one with less vias, right? So I'm gonna go for the top one and then click on N. All right, that's finished. And you can see here everything's wired here. For the wiring on the top, essentially what it does is just cut out some of the coppers because the copper cannot cover the whole plate, so it cut out so you can make a choice for that. Also, you can click on each wires and you can increase like go to property and then increase the width. Let's say your load will need more spaces, like more current, so you may increase it to, let's say 10 or whatever you want to, and then it will increase it. So that's one way to do it, but this one's a simple one, so I'm not gonna go over all of that. Besides, there's a lot of things to learn around here, so I'm gonna keep it as simple as possible. All right, now we got our wiring done. What we need now is just create a PCB. the 3D model. So we want to come over here and then click on 3D. All right, let's see how does it look. All right, and this is our board, how the PCB board gonna looks like. So we got the LED. I mean, this is this is red, this is green, but you know, you're the one who's gonna solder that thing, so you gotta pick up the right one. Both one are red. It's just the 3D model of the component that looks like it's gonna be red, but now when you got your own LED, you put red in here, and then you're gonna put green in here. So when the voltage goes in, it's gonna turn on, telling you that okay, there's a voltage, and if the regulator is working, this one will turn green, so we can plug in any 5 volts load right here. And those are capacitors. I know that I could do a better job on how those elements are kind of laid out. I'm still learning, so all right. So we got the input and then we got the outputs. What I need now, let's add some hole around those things so we have like a mountain holes. So I'm gonna go back to my layout here. There's multiple ways to do it. Maybe you can make the profile for the board itself, like making a new design and then bringing in. Alright, but I'm gonna keep it simple. Maybe next video I will show you how to do that. So what I'm gonna do is add some non-plates or through holes. So you want to click on one of these, right? And these things are mills, you know. Mill is sometimes I get confused with those mills, kind of like I like working with inches or millimeters. This one is just got to do some conversion. So I'm gonna go like a 50, okay? And then I'm gonna put them right up. Shoot. All right, let's see. 50. And then I'm gonna put one to the edge, another one right about there, and one more right here. This is just I'm just highballing the whole thing here, so I could do more professional work, but it's look good to me. Let's say okay. So we have a 4 mountain hole with 50 mil. All right, now we go back. We're gonna save this one. Uh-oh. Let's say we call it what? 40 regulators PCB layout, okay? PCB layouts. PCB layouts. All right, perfect. And now we can save it. And then we come over here. This is all right, we need to update it. Click on this. So we got our mountain holes. All right, now we got the mountain holes. This one kind of a little bit off, like close to the mountain hole. Let me go ahead and move a little bit. If I move it now, we'll have to do the wiring again. Oh, it's fine. Let's move that. Okay, I'm gonna move it right about there. Okay. All right, let's move it right there. All right, it's perfect. And maybe we won't need to. Let's see, double click the middle mouse to kind of center the whole thing. Oh, just move it right, okay. In Kaikai, if you move some component, you have to do the wiring again. Let's move it right about there. All right. Let me do checking rules. So we're gonna want check design rule, see that everything is all right. All right, no errors, nothing at all. So I'm gonna save it. Just Control X or just click on save here. Oh, no, right there. All right, let's come over here again. And yeah, this is our board. This is the PCB board. You got the inputs and the outputs. And yeah, now what we want to do is just export like we don't to send this to the manufacturer, you have to create a file called global file. So we want to do that next. So we want to come over here and then you want to go to manufacturing. Okay, let me sum this one up. Okay, I'll go to manufacturing And then we go to computer aided mechanical manufacturing view, okay, of course. And then you're gonna see the board, all the components right here. So that's how the component will looks like. So we got the input and output here, another component there. I mean, I should have done a better job on this one because this is gonna be a little bit harder to hand solder. I think so, but anyway, like I said, I'm still learning this stuff. So, all right, that's how the board gonna looks like. And then when you manufacture this one, you just plug in each component and then you solder the whole thing. So you can kind of look around, explore the whole thing. So let's see the board, the area. Let's like all the dimensions, width, height, and then you have the pad. Those pads are kind of like a little holes in there, and also those are surface mount, of course. Yep. And drill how many holes. So we can count how many holes here. Here we seem like we have 15. We have those are like for the components, and we have some non-place two holes. Those are like the edges, like the mountain holes. And let's see, four non-mountain hole, and these are for the component here. There's different metric and then those are like packaging, like measurement. You can just you can just look around, but I'm gonna close it. We don't need any of that. All right, this is a PCB, and then I was on the cam. So when you did the preview, everything looks right. Just you come over here, second one, and then you can generate a bill of material. So you go to assembly, assembly, yeah. Click on that one, and then you can export this bill of material. The bill of material can essentially tells you all the components that goes into the PCB. So here we have the resistor, LED, and so it can help you like let's say the manufacturer have to do the assembly of each component for you, so there's no what component they're going to put on the board, so everything work as expected. All right, so here, so you can, like I said, you can export this one. Click on it here, and then you export it. You can export that zip or whatever. All right, I don't need that one. What I'm gonna need is just this cover file. So if you want to send it to the PCB way or like a TLC PCB or something like that, those are different manufacturing. So they're gonna need a cover file. So you click on this one, and then let's say we want it as a zip file, and now you're gonna process the whole thing, and then you give it a name. So I'm gonna put on my download folders. So that would be the name for the regular. Give it some fancy name you want it to. So click on save, and then when the process is finished, just click open. So we're gonna open and see what's inside. Okay, here we go. Is that the right one? Nope, it's the second one. Perfect. So we want to go to cam output, and then OBS. We don't need that one. Maybe space here, default, and we have a Gerber file here. Okay, open it. So we got all this information that they need. Copy paste all the information that they need to kind of print the board for you. Alright, I think that's all I need to do. You can save all the changes you made here. You can explore the whole thing and see all the options that you have. So you can just discard it. You can save it, but I don't like saving it. I like keep the default in case I make some changes that I don't like. So keep the default. So we discard the whole thing. All right. Here we have this is the board. So if you print this board, and then you have all the components, so you have this little regulator, you can use it to do whatever you want to. So just keep in mind this will be 5 volts, and this the inputs will be 9 volt. This it kind of take up to 20 volts, but I don't think it's a good idea to go up to 20 volt. Just let's say keep it around like 15, something like that, just to keep safe. And also, depending on current that you might be pulling out of here, you might need some heat sink here. You could use like also like Ohm's law. So let's say you have 5 volt here, 10 volt coming in, and this resistor is taking out like a 5 volt, right? So you do the like the rest of the voltage. So you do like a 5 volts, like 9 minus 5. This is a 4 volt. What happened to those 5 volts? They kind of like dissipate as a heat. So you're gonna make sure you kind of place some heat sink in here. So use ohms law. So we have 5 volts, like a 4 volt, yeah, 4 volt that kind of go to dissipate here, and you use the current that's shedding out of here, and then you use the power dissipation P equal UI, and then you find like how much power is kind of dissipating, and from that you can judge if you need a heat sink or not. All right, this video is getting a little bit longer, so I'm gonna stop it here. Next time I'm gonna do like make some enclosure for this one.